So we are doing polynomials simplifying rational expressions. So rational expressions, you have the word ratio built into rational, and basically that just means a fraction. So the two key concepts to keep in mind when simplifying rational expressions is one, anything divided by itself is still a version of 1. Okay, it's still a form of the number 1, or the quantity 1. Anything multiplied by any version of 1 is still itself. So when we look at something, for example, if you have 2/3 and you multiply it by anything that is multiplied by it, or divided by itself, that this is still basically a version of 1. It is still a form of 1, usually called a unit fraction. Okay? So when you multiply anything by a version of 1, it is still itself. Its quantity has not changed, just its form. Common examples of this is whether you have 5 dimes or 2 quarters. The value is still there, it's just how it's broken up changes. So this concept remains the same even when we're working with polynomials. That anything multiplied by a version of 1, and a version of 1 is anything divided by itself, that it is still itself. So even though this looks a lot funkier and messier and bigger and more complex, it's literally nothing more than just 2/3. And to kind of show that 2/3 and this quantity is the same, because if we pull out the 2, the greatest common factor, and factor that out, and the 3 from down here, then this is what you'd be left with. And then you go, okay, well that's basically 2 times n plus 4 and 3 times n plus 4. And here these two numbers are divided by themselves, and anything divided by itself is still a version of 1. So basically you have 2/3 times 1, which we know is itself. So if you think about rationalizing expressions in this sense, then it becomes a lot easier. So let's go ahead and move our paper up. So reiterating that oftentimes you'll see these being canceled out, is what some people call them. Some people might refer to them as simplifying, because basically you're simplifying it down to what its true self is, which is 1. So even if you have something that looks like this at first, and looks like a big mess, very complicated, if you start recognizing where the unit of 1s are, then you can, if you wish, rewrite it and simplify them that way. But to be honest, you can also just simplify them by crossing them out where they stand, as long as you recognize that you have 1 of something in the numerator being divided by its identical self in the denominator. And that is just a version of 1, or a unit fraction. Unit meaning 1. So this whole thing here was just a fancy form of 2/3 again. So when you go to actually rationalize polynomials, you might see something that looks like this. And at first you're like, ooh. But it's basically a 2-step process. Is one, you're going to simplify to the factors. So each one of these you're going to try to break them down to so they're nothing but their factors. Excuse me. And then you're going to simplify the unit fractions by across an amount and identifying that they're just a version of 1. So first is we put these as their factors, and just a little quick note of a unit fraction is any number divided by itself. Okay. So this number up here, we can put in its factors are here. This trinomial here, we have its factors here. And then we can start doing step number 2, which is recognizing unit fractions. Now here is a common area where a lot of people get mixed up at first. Let's go ahead and scoot this up. Is that they want to say that their answer is, well, then x plus 1. And that's not true, because of the fact that since these simplify down to 1, that means this is 1 times 1 in the numerator, and this is 1 times 1 times x plus 1 in the denominator. And so this x plus 1 isn't the answer by itself, but the true answer is 1 over x plus 1. So any expressions that are on the denominator stay in the denominator, unless obviously you have something raised to the negative exponent. We'll be a little bit more grammatically consistent there. Alright, well, I hope this helped. And that is how you simplify rational expressions.